Hello and good evening and welcome to Maths Fest. So today I am with Akriti and we are going to learn after a very long time today a new topic, that is domain and range. Coming directly on the topic, so what is a domain and what is a range? So Akriti beta, first of all you should know how a graph is being made. To make a graph we need two axes. One is x-axis and one is y-axis. And any rule that we define for y as compared to x, this y, anything that we show on y-axis is known as dependent variable. What it is known as? Dependent variable. On the x-axis it is known as independent variable. Independent variable. X is known as independent variable, y is known as dependent variable. Okay. And we can define any rule, like if I say y is equal to x plus 1. So this is known as a function. This is known as function. Function means I have shown you the function machine, I think. Let me show you again. So let us see the function machine first. So this is a function machine in which the set of numbers which are going to throw into the machine is known as independent variable, and the number which comes out is known as dependent variable. So 1 is independent variable and 2 is dependent variable. Are you getting it? Similarly, if I throw 2 into this, what will come out? 3 will come out. So I will say that 3 is dependent variable and 2 is independent variable. Are you getting it?
Yeah.
So the things which I show on the x-axis are known as independent variables, independent and dependent. Now these independent variables are known as domain of the function. What it is known as? Domain of the function. And this y values are known as range of the function. Okay. Sometimes you have to decide whether the given function is value for what is the, if I ask you what is a domain means, I am asking you the number of values for x-axis in which the equation can exist, the function can operate. For example, if I am talking about the number of apples that a person eat on a daily basis, so I am going to ignore 1.5, 1/2, 1/3/2, like those numbers I will include. I will take only whole numbers. I will take only whole numbers. I will not take negative numbers. So it is decided that the given function is based on what are the values on which x can be taken, and with that respective x what are the values in which y can come is known as range. The values on which y will come is known as range, and x is the domain on which the function exists. Are you getting it? Tell me.
Yeah. Is there like any set definition though?
Okay, yeah, there is a definition. So I want you to write the definition as well.
Today we'll practice finding the domain and range of various functions. Let's check it out. What are the domain and range of y equals the negative absolute?
Okay, so can you tell me what are the values for which, what are the values can x take?
It
What?
can be anything.
It can be anything. So domain of this x is going to be real numbers, R.
Okay.
Okay. And what are the
Yeah.
values of y that can come?
It has to be a real number as well.
No,
Or can it be anything?
no, it can't be anything. That is the main game. You have to understand that y can't be anything. Let me show the graph of this function, okay? how this function will operate. Wait. Okay, it came to an end.
Great job today.
Can you share your screen if you want? Or is it, are you able to listen to this?
I can hear it.
Represents one
Okay.
edge of our range, either the minimum or maximum value. Because the absolute value has a negative multiplier in front, know that as its value increases, we will be subtracting bigger and bigger numbers from 3. So this function will only produce y values less than or equal to 3.
Did you get that? What is the range?
Okay, because it
Range
has a
is,
minus sign.
yeah, because it has a negative sign, so on negative axis it can take any values, but it cannot be
Yeah.
positive. So what is the minimum value it can have? Means what is the maximum value it can have? 0. Maximum value that can have is 0. So 0 plus 3 will be how much? 3. So the range will go from negative infinity to 3. And please note that these common brackets are used, that means those numbers are not included. If I use a square bracket, means 3 is included in that.
Okay.
Okay?
With a bracket next to the 3. It indicates
So this is range, this is domain.
It also makes sense if we consider its graph. This equation represents value function that has been vertically reflected over the x-axis, shifted left 1 and up 3. Sure enough, the function looks.
You understood how this happened?
Yeah.
First, the graph of y is equal to x-axis was like this. Y is equal to mod x was like this. So if you make a negative image of this graph will go down. Then they shifted 1 unit towards the left because they added 1. If I want to make 0, I will subtract 1. So it was 1 unit towards the left and then 3 units above it. Okay, so this is the graph. Are you able to see this?
Yeah.
Now what is the range? Can you tell me? It starts from 3. It is the
And
maximum value.
goes on
Go
till
at the
negative
bottom. So you will
infinity.
say minus infinity to plus 3. But what is the domain? Domain is, it is valid for all the values of x. So domain is minus infinity to plus infinity.
It looks like it extends infinitely left and right, only exists at or below y equals. So our domain is all real numbers, and the range all y values negative infinity. Let's look at another function. This time we have a square root function.
Okay.
Why?
Let's do this. Let's I will ask you some questions and then you will tell me. Okay. Okay. Tell me, is the under root of any negative number possible?
Under root of any negative number.
Yes. Can I find under root of negative 4? Can I find this?
That's not a real number.
That's not a real number. Means I can't find any real number with negative under root. Are you getting it? So
yeah.
that means x minus 3 must be greater than or equal to 0.
Yeah.
That means x must be greater than or equal to 0. Sorry, 3. X must be greater than or equal to, this 3 will go on the other side, it will become 3. So what is the domain of this function? It is 3 to infinity. Are you getting it?
Yes, sir.
You can't have x as 2 because 2 minus 3 will be minus 1 and under root of minus 1 is not defined. So the minimum value that you can have here is 3. So the domain starts from 3 and goes up to infinity. Now what is the range? Range is the set of all the values of y which can take place. So that means you can see this value can minimum. What is the minimum value of this? It can become 0. The minimum value it can become is 0. Anything that comes out of under root is always positive. So the minimum value it can become is 0. So if it is 0, what is the starting point of the range? It is negative 4. And for infinity it can go to any value. So negative 4 to infinity. The infinity you have to write in this bracket. Are you getting it?
Yeah.
Sure?
Okay.
Okay. Now let us see the video.
Y equals 5 times root of x minus 3 minus 4. When working with square roots, know that whatever is underneath the radical must be greater than or equal to 0. This will help us find what x values are and aren't allowed to plug into our function. The radicand of this function is x minus 3. We know that x minus 3 must be greater than or equal to 0. To isolate x, we should add 3 to both sides. This means that as long as x is greater than or equal to 3, the radicand won't be negative. So our domain, all x values greater than or equal to 3. We also know that the value of the radical itself must be greater than or equal. So to find one end of our range, we can find the value of y, higher radical is 0. Simplifying the right-hand side, that when the radical equals 0, y equals negative 4. This could be the minimum or maximum value.
Understood? So
Yes, sir.
if you want the definition of this, the definition is like this. The domain is the set of all the values of x that x can take place. Okay? Domain is defined as, I will write it for you so that you can understand
Yeah,
it better.
okay.
You can write better. Domain is defined as, so it is a group, you can say it is a group, but we will use the word set. Set of all the real values of x for the given function. For the given function, you can say the function is given as y is equal to f of x, and it can be anything. It is defined as function of x. We are doing some function on the independent variable x. So domain is defined as the set of all real values of x for which the given function is defined. The given function is defined. For example, under root of, suppose I am writing under root x. So negative, for negative numbers, this function is not defined. Are you getting it? The
Yeah.
function has to be defined, means function is operatable. Okay, see, suppose you are a human being. I ask you to do some certain set of functions. I want you to rotate this hand, you can rotate like this. I want to rotate this hand, you can rotate like this. But if I ask you to dance in Bharatnatyam, so you can't do that if you haven't practiced. So for
Yeah.
same goes with the function as well. For the function to be defined, it cannot operate on any number. There is a certain set of numbers on which it is defined. So those numbers are known as domain of the function. Understood? If I ask you about what is the range, so we will write range is the set of, range is defined as the set of all real values that exist in the domain of function of x. When I am writing fx, means I am writing function of x, or you can say y slash y. Okay, range is defined as a set of all real values that exist in the domain of function. With every domain you will get a range.
Yeah.
Understood?
Yes, sir. Let me just write this down.
Okay, sorry.
It's okay. I'm almost done. Just have to. Yeah.
Done?
Yep.
So let's do this question. Okay. Now they are asking you what is the domain of the logarithmic function. So this is the graph. You can see the graph.
Yeah.
So can you tell me the domain? It is existing on this value 0.
Yeah.
and it is going
So-
towards the right axis. So that
So
means,
that means it's from 0 to infinity.
Correct.
Positive infinity.
0 to infinity. That means you can say the set of all real x such that x is greater than or equal to 0.
0.
Are you getting it?
Hmm.
Okay. Okay, it is incorrect. I thought so. Okay. So it does not exist for x is equal to 0. Okay.
Oh.
Logarithm is not defined for x is equal to 0. It will be given here. I thought so initially. So that you can write this definition as well. The domain of a function is the set of all possible x
Oh,
values.
yeah.
It is the same.
Okay.
The range of the
Yeah.
function is a set of all possible y values. For the logarithmic function y is equal to a log bx minus h plus k, the domain is x greater than h, which is all the numbers to the right of the vertical asymptote. X is equal to h. So the range is all real numbers. The domain of this logarithmic function is x is greater than 0 since all the possible x values of the function are to the right of the vertical asymptote x is equal to 0. So they are saying that whenever you see the graph, this point is known as asymptote. This point where the graph is just going to the same line.
Okay.
So this is known as asymptote. Okay. So the graph exists after this only. So you will say it is x is greater than 0. Understood?
Yeah.
Okay. Next question. What is the range of this exponential function? Tell me what is the range of this exponential function? Logarithmic function.
From, okay, so it starts from 0, goes on to negative. I mean to positive infinity.
Yes. So
But
you
then
can,
so domain is negative infinity.
domain is negative infinity or positive infinity, my dear?
Domain.
Okay,
And then
domain.
range is
Okay,
positive.
fine. So they are not asking the domain, they are asking the range.
Oh, okay, so range is positive infinity because it's just going on.
Okay, so it will be y greater than equal to 0, right? Y is
Yeah.
greater than or equal to 0. Again, this is incorrect because again,
Yeah, I was thinking because it's like the same question as last time, so it wouldn't be equal
but
to
this time it was a range. So I thought so whether to take the chance or not. So you can say the range is either y is greater than k, which is the all horizontal asymptote. So in this case, you will draw the horizontal asymptote. So this is horizontal asymptote and y is greater than 0. It cannot take 0 values. Alright. Okay, tell me what is the domain of this function? This is very easy.
Domain is from negative to, would it be just infinity?
Negative infinity to positive
To
infinity.
positive infinity.
So that means set of all real numbers. You can say x is set of all real numbers. So all real numbers. You will write all real numbers. Okay. Next question. Now this is easy for you. What is the range of this exponential? So range is y is
Greater than 0.
greater than 0. Okay. Now what is the range of this function? Tell me what is the range of this function?
The range is it negative? Is it from 0 to negative infinity?
No, range. I'm not talking about domain, my dear. Range is the y-axis.
Yeah, there's nothing on the y-axis.
No,
It's
it
just,
is going in the y-axis.
oh.
It is
So is
going
it
towards the
positive
y-axis. So
infinity?
it will go ahead. So it will be, see, 0 is also included here. 0 is also included here. So you can say y is greater than or equal to 0. Because y
Okay.
takes on this value as well. You can see the dot. If it is a,
Yeah.
okay, if it is a straight line which is not meeting, then you can say, okay, it cannot take those values. But right now you can say range is from 0 to infinity. That means y is greater than or equal to 0. Understood?
Yeah.
Next question. What is the range of this function? Tell me. What is the range of this function? What are the
From
possible
0 to
values of
negative
y?
infinity?
How much? 0 to
Positive
infinity.
infinity.
That means y is greater than equal to 0.
Yeah.
Next question, beta. What is the domain of this logarithmic function? Tell me.
Positive infinity.
Okay, x greater than 0, right?
Hmm.
What is the domain of this function? All real numbers?
Yeah.
Okay. What is the range of this function?
This is from. Is that 1?
Range, yeah, that line is 1. That
It's
line is 1.
1. So it's from 1 to positive infinity.
So y greater than 1, you are saying.
Yes.
So y greater than 1 is this one, okay?
Yeah.
Good. Next
Oh, it's
question.
a quadratic graph.
What
No,
is the
it's
range of this function?
from -9 or
Yes.
-8?
Yes, minus 9.
-9, okay. From -9 to positive infinity.
So you can say y is greater than equal to minus 9.
Yeah.
What is the domain of this function? All real numbers?
Yeah.
See, any graph which is like this, it is all real. Okay, what is the domain of this function?
From 3 to negative infinity.
So you will say x is less than. How you will say that? X is less than or
Equal.
less than or equal to 3. X is less than or equal to 3. Are you getting it?
Yeah.
Okay. Okay. Under root of x. The graph is not there, but what is the what is the domain of this function? Tell me.
X has to be greater than 0.
And equal to 0 as well.
Oh yeah, because it'll just be 1.
Under root of 0 is also defined.
Yeah.
Okay. Tell me for this, beta. What is the range of this function?
Y has to be greater than 0 because it's an absolute value.
What about equal to 0?
Yeah, it can also be equal to 0.
So that means y is greater than equal to 0. Alright. Next question. What is the range of this exponential function?
It has to be above 4 though.
Above 4?
No, wait, no. It's above 1 because you can do it to the power 0 and your answer will be 1. So I can.
Can't it be less than 1?
It can be because you can do x as a negative number.
That
So
means,
could you technically be
but it
all
can
real
never
numbers?
become 0, but it will never become.
Yeah, it won't be 0.
So that means y is greater than 0.
Okay.
Okay?
Yeah, okay.
It can never become 0, but it is always greater than 0. So you can say y is greater than 0. Good.
Mm.
Next question, beta. What is the range of this function?
X is greater than y has to be greater than 0 in this.
Oh, okay, range. Range, you are saying anything that comes out will be always positive.
It has to be greater or equal to 0.
Greater than or equal to 0.
Hmm.
Okay. If I ask you what is under root of 4, tell me. What is under root of 4?
2.
It is always 2. Okay. Can't it be minus 2?
It can be because of the rule.
This is a very typical question. Can under root 4 be minus 2? See, try to understand, beta. Minus 2 square is how much? 4. Okay? Minus 2 square is how much? 4. 2 square is how much? 4. If I ask you x square is equal to 4, So what can be the value of x? It will be
Either
plus
minus
minus
2 or
2.
2.
It will be plus minus 2. Are you getting it?
Yeah.
But if I ask you x is equal to under root of 4, what can be the values of x? Tell me.
2 or minus 2.
No.
Oh, you're asking for x.
Yeah, I am asking if x is equal to under root 4, what is the possible value of x? See, if I am solving this x square is equal to root 4, then surely we will get two values of x, which is plus 2 and minus 2. But if I ask you x is equal to under root 4, what is the value that I am going to get? Will I get plus 2 and minus 2 or only plus 2?
You can get either.
I can't get either. I will get only plus 2. Why?
Yeah.
Because if I ask you minus 2 into minus 2 is equal to minus 2 square, okay, which is equal to minus 2. I can't, there has to be 2 minus 2 inside this. Minus 2 into minus 2 is minus 2 square. But if it is 4, I can get only one answer, that is the positive one. So by going with that logic, so square, I can take only positive numbers inside the square root. With those positive numbers, I will get only positive values of y as well.
Yeah.
Including 0. So y should be greater than or equal to 0. Are you getting it?
Yeah.
So this is the range of this function. Very good. Now tell me, what is the domain of this function? Very easy question.
This is like all real numbers.
Yes. So domain of any modulus function is always all real numbers. Okay. What is the domain? Domain of any modulus function. Modulus function means the which comes under two parallel lines.
Oh, okay. Anything in an absolute value.
Yes, absolute value. So those functions are known as modulus function, and the domain of any modulus function is always set of all real numbers. Now here we have some problem with this square root. So square root does not exist for negative numbers. So you have to be very careful with your logic, so that whatever comes inside this square root has to be positive. Can you tell me what is the domain of this function?
So it has to be positive.
So on what values of x it can be positive, or it can be 0 as well. That is also allowed. You are having negative x inside the square root.
So it just has to be greater than or equal to 0.
Yes, negative x has to be greater than or equal to 0. You can make the equation like this. Very well said. Negative x must be greater than or equal to 0. So what will be x then? So in inequalities, there is there are two rules. I am going to tell you both the rules. Okay. See this. If I say 4 is greater than 2, can I say that minus 4 is less than minus 2?
Yes.
See this. 4 is greater than 2, so minus 4 is less than minus 2. Are you getting it? When we do the negative, when I multiply the whole equation by a negative number, the sign will be changed. The sign of inequality will be reversed. Are you getting it? So try to understand, if x is greater than 2, then minus x is less than minus 2. Are you getting it?
Yeah.
This is a rule in inequality. See, the problems that we are dealing with is inequalities. Equality means it is an equation. So if it is not equality, then it is inequation. It is known as inequation. So we are dealing with inequation. So I am saying there is one rule. When we are multiplying the whole inequation by a negative number, the symbol gets changed. The sign of the symbol greater than will become smaller than. This is the first rule. Then there is one more rule. So tell me, if 4 is greater than 2, then 1 by 4 is less than 1 by 2. Are you getting it?
Yeah.
If I do the reciprocal of a number, the symbol will get reversed. So you have to understand this. If I say that 3 by 2 is greater than 1 by 2, Then you reverse this, you will say 2 by 3 is smaller than 2 by 1. Okay, so here minus x is greater than equal to 0. So x is less than equal to, minus will go on the other side, minus 0, which is equal to 0 again. So the answer is x is less than equal to 0. So the domain of this function is x is less than equal to 0. Understood? Sure?
Yeah.
Good one. Next, what is the range of this function? Tell me what could be the range of this function.
The range has to be greater than 2.
Greater than 2, can't it be 0?
Oh, because you can minus a bigger number. Then it's just greater than or equal to 0.
Very good, Akriti. Well done. Good one. What is the domain of this function? As I told you earlier, it's a
anything,
modulus
all
function,
real.
all real. What is the domain of this exponential function? Domain. For what values of x can this equation exist? What are the values of x for which this equation will exist? Tell me.
That can be anything.
Anything. So it is all real numbers.
Yeah.
It is all real numbers. All right. Good one. Next question. Excellent. What are the domain and range of this function? You have to tell both the domain and the range.
Oh, okay. So
tell me what is the domain first. Tell me what are the values of x for which the function can exist. So we have the function as under root of x plus 4. I am writing it. It is minus under root of x plus 4. Yes. So the function is y is equal to minus under root of x plus 4. Okay. Tell me, if I want this function to exist, then I have to say that x plus 4 must be greater than equal to 0, because the negative numbers in the under root is not allowed. Alright. This means x is greater than or equal to, this 4 will go on the other side, minus 4. So the domain is, you can say x such that x is greater than equal to minus 4. Are you getting it? Tell me, any doubt?
Yeah. No. I got it.
Can you tell me what will be the range of this function? Apply your mind logically and tell me what could be the range of this function. What are the possible values on which, if I draw the graph, the y can take place?
The range also has to be greater than -4.
No, first tell me, let us take 0 first. Can y be 0? Tell me, can y be 0? We will talk on 3 aspects. Can it be positive? Can it be 0? Can it be negative? Okay. Can this ever be positive? Tell me, can y ever be positive with a negative sign outside? Can it be ever positive?
No.
No. That means it cannot be positive. Can it be 0? Can it take 0 value?
Yeah, it can.
It can take 0 value. Okay, good one. Can it take negative values?
No.
Why it can't take negative values?
Oh, no, it can take negative values.
It will only take negative value. Apart from 0, the only value that it can take is negative value. Okay. So the range is y is less than equal to 0. Are you getting it? The range is y is less than equal to 0 and domain is x is greater than equal to -4. Understood?
Yes.
Sure? Okay. Next question, beta. Y is equal to log of x minus 1. So first of all, you have to understand that the negative of a log is not allowed. This can't be negative. This can't be negative. Are you getting it?
Hmm.
So x should be always and log of 0 is also not allowed.
Yeah.
So that means x must be greater than 1. X must be greater than 1.
Greater
This is
than-
the domain. So x is greater than 1 here as well. Okay, now tell me what is the range? What is the range of this function? Shall I draw the graph of this as well to make you a better understanding?
Sure.
Log of x minus
Sure.
1.
Yeah, I'm a better visual learner.
Yes, yes, yes. Why not we, when we have the possibility of all those things, why not to use it?
Yes.
So it is log of x minus 1. Okay, can you see the graph?
Yeah.
Okay.
So it's
So
from
range you can
negative
see,
infinity.
range is from negative infinity to,
Yeah.
so if I talk about this, it is crossing the line slowly. It is slowly
Yeah.
increasing, but it kept on increasing.
Hmm.
Can you see? As I zoom out
Yeah.
more, you can see it is increasing. Slowly it is
Mhm.
increasing. So that means we
Yeah.
can say it is from negative infinity to positive infinity. That means it is the set of all real numbers.
Yeah.
So if I need to take bet on this, I will take with this. You tell me.
Yeah.
You tell me.
Yeah.
You also go with this only,
Yes.
or you want to change your mind with any of these options? X greater than equal to
No.
1, or y is greater than 10. Shall I
No.
check this?
Yes.
Oh,
There we go.
so it got correct.
Hmm.
Okay. Next question, beta. What are the domain and range of this function? Okay. So let us check it out. Y is equal to modulus of minus 4x plus 1. What is domain and what is the range? As I told you, any modulus function, that domain is set of all real numbers. So it is but obvious that you have got these two options, first and second. Okay. Now you
Yeah.
have to choose between the range first and second. Tell me what could be the range of this function. What is the
I think it's the first function.
Hmm?
I don't know. I don't think it can be equal to 1.
Why it can't be equal to 1? If you take x is equal to 0, what is the value of y?
Okay.
If you take x is equal to 0, what is the value of y?
It's
If I
just
take
1.
1, so it is equal to 1 as well.
Yeah. Okay. Then it would be that.
Okay, then it could be the second one. Understood? Y
Yeah.
is greater than equal to 1. Okay, next question. What is the domain of this function? Tell me for what value of x that this function will exist. Is there any limitation with x?
No. For this one, no.
You want to see the graph of this?
Sure.
Okay. So 1 by 5, 1 by 5x plus. Please note this down so that I can make the graph. I will just ask you.
Okay. Wait. Let me note
Note this
down.
value first.
Yeah. Done.
Done? Okay.
Yeah.
So what is the function? It is first 1 by 5.
Yeah. Y is equal
Okay.
to 1 by 5.
Okay. So 1 by 5 into, in bracket, it is
1
again
by
1 by
5.
5.
Yeah. In brackets, full thing bracket.
Okay. 1/5. Then whole to the power. What was whole to the power?
Whole to the power x plus 4.
X plus 4. X plus 4. And then?
And then it's just minus 4.
Minus 4. Minus 4. I think we made some mistake.
No, we didn't.
X plus 4 minus 4. Okay, this time I will write in one go. So 1/5 into 1/5 to the power x plus 4 minus 4. Okay, we got the function now. Let us check it out. Okay, so this is the graph. Can you see the graph?
Yeah.
It is going like this, and this line is the asymptote. Let me zoom it out. So asymptote is minus 4. Okay, it is taking the minus 4 value as well. Are you getting it? See this minus 4. If I zoom it, let me see. It is touching y-axis at minus 4 or not? Yes. It is touching the y-axis is minus 4, but it cannot be minus 4 because this can't be negative. See,
Yeah.
1/5 into 1/5 x to the power plus 4 can't be negative. So that means it is not going to touch this minus 4. It will always be closer to minus 4, as closer as it can. But it can never cross minus 4 or touch minus 4. This is known as asymptote. This is known as asymptote. So what is the range of this function? The range of this function is y is greater than minus 4. Are you getting it? Y is greater than minus 4. As far as x is concerned, it can take all the values of x. It can take all the values of x. For x, there is no rule. So that means the domain is the set of all real numbers, and range is y is greater than minus 4. It is not equal to minus 4. Are you getting it?
Yeah.
Let us check it out. Awesome. Next question, beta. Very easy. Domain and range.
Oh, x can be all real numbers.
Okay, and what could be the range?
Range.
Can it be negative?
I'm checking that. Yeah, it can be.
Can it be positive?
Yes. No.
Okay.
Wait. Can it be?
It can be positive. Okay. What is the maximum positive value it can have?
I don't think it can be positive.
Why? If I make x is equal to minus 7, minus 7 plus 7 will become 0.
Oh, wait. But
So
then, okay, then 0 into minus 7, then it's 8. Max is 8.
So y is less than or greater than, less than or equal to
8.
8. Are you getting it?
Yes.
Sure?
Yeah.
So you have mastered this
Hold
skill.
on.
So we got 2 incorrect questions just in the beginning of the question. And after that, all the questions were on the right spot on. Right?
Yes.
Well done. So one of the topic has gone, that is domain and range. Okay? Okay.
Yeah.
Solving quadratic equations. I think I have taught you this. Factorizing, solving quadratic equations.
Yeah, a lot of this has already been taught. I'm just wanting to go over it.
Okay.
Because this is
So
where
Direct and indirect variation, that also is being taught to you. You can play around with certs also. We have done so many questions on certs, I think.
Yeah, I know we've done all of this, but this is still like, you know, the things that I'm kind of scared
We
of.
will start with transformation now. Okay, we will start with transformation. Transformation is a beautiful topic. Okay, the sheet that we did is in pre-calculus. Okay, you can just go
Okay,
through.
recalculus.
You can go through with
Okay,
more of the
recalculus.
topics if you want. But right now I am going to do the transformation, and that will you will get in geometry. Triangles congruence. Okay, so this is congruence transformation. So you have got so many sheets. See, there are 16 sheets on congruence transformation, and there are 6 sheets on dilations. So if you do 16 plus 6, there will not be any iota of doubt in transformations for you. Okay?
Okay.
So first we will start with classify congruence transformation. Look at this shape. Which image shows the reflection?
C.
A, B or C? Tell me.
C.
A.
A. No, C.
C. Yes. Okay. So C shows the reflection. Okay, good one. Okay, look at this shape. Which image shows the reflection?
C.
Good.
Again, C.
Tell me which shape, which image shows the rotation?
A? Yes, A.
A, sure? Okay, so if you are rotating
Yeah.
around this point, it will come around this.
Yeah, yeah.
Okay. Okay, good one. Look at this shape. Which image shows the rotation?
B.
B?
Yeah.
Okay. Which image shows the reflection?
A.
Which, look at this shape. Which image shows the rotation?
B.
B?
Yep.
Sure.
Yeah.
So, how you are rotating?
Like from that point and then just keep going. 3
Okay.
turns.
Let us check it out.
Yeah.
You are saying B, right?
Yeah.
Okay. So, I am rotating this. I want you to see how B is working. So, you are saying that I think
No, go back.
this is
No, no, no. Keep just like that.
like that.
Yeah.
So, this is B, right? Good.
Mhm.
Good one. Good that you located very beautifully. I was getting confused. I didn't get that easily. Okay, good one, beta. Shabash. Next.
What? Hey, no. What is this?
Okay.
How is here?
I told you that I had some doubt in that. So that's why I
I
changed
thought it
it.
was B. Oh
Okay,
no.
let us check it out whether why it is not B or how it is
Yeah.
B. So what was the initial shape? Let us check it out. The initial shape was like this. Okay. So you see that this is a smaller line, this is a slanting line, and this is a more big slanting line, right? See this. If I want to, if I am rotating this, see this. If I am rotating this, this is the slanting line. You have to understand. Slanting line remains here. If I make,
Okay.
okay, this is not the shape. If I rotate more, see this. If I
Yeah.
rotate a bit more, and bring this line here. See this. This line resembles to this line. Are you getting it?
Yeah.
You can see the C part here. You can see the C shape coincides with this. I am just rotating the first shape. See, the shape involves three sides. One is, okay, so I am coloring it now so that you can better understand. Can you see this color?
Yeah.
Can you see this color as well? Okay.
Yeah.
Okay, now see this. The initial shape given to us is like this. The initial shape is given like this. Are you getting it? I can relate the
Yeah.
initial shape with this. Okay. Now I am rotating this and you have to check which shape resembles to which one. So this is the first shape. So that means rotation is not been done. This is no rotation is done. It is the same shape. The same shape has been copied down. All right.
Yes.
Coming to the B part. Now see carefully what is happening. This is the yellow line. So yellow line I had to make it like this. You see, this is the yellow line. You have to understand. This line is the same line as this. So when I make this line as this is the shape that I got. But B is different from that. B is
Okay, good.
different from that. So B could not be the answer. So the only option left is C. But how C? So I will just mark it out. So this line is actually made as a horizontal line. You can say this. This line resembles to this vertical line resembles to this line. All right. This slanting line resembles to this slanting line. You can see this. So this is the horizontal line, vertical line shifted here. So this shape and C
Yeah.
is same. So the answer is C.
C.
Understood? Look at this shape. Which image shows the reflection?
Reflection?
Yes.
None of these.
None of the shape shows reflection.
How is any of these a reflection?
So my dear, there are two kinds of reflection. One is horizontal reflection when you are looking into the mirror, and there is a water reflection when you are looking into the river.
Oh,
So you have to check it out.
okay.
The reflection can be a mirror reflection or the river
Yeah, but
reflection.
like I tried that horizontally, no, none of this is reflecting, and also river, none of it's reflecting.
Vertically also it is not reflecting.
Yeah, it's not, see?
Yeah.
What do we do? Are we missing something?
Let us mark any incorrect answer and then we can check with the solution. Okay. So
Yeah,
if you want to
because
go with any, if you want to go with any option, which option you will go?
I would say C. It seems like a safe bet, but like then we won't know how. But okay, C.
Okay, if we make the reflection of this and rotate this,
Then it is C. Yeah.
then it will be C.
Yeah, but it makes no sense.
But deliberately we know the answer, but deliberately I am marking incorrect option so
Okay,
that we can
yes.
see we can see
We
what
can
is
find
being
out
done.
how.
So the answer is
It's
B actually.
B.
Okay, so they are saying that the reflection flips the figure over the line to create the mirror image. A rotation turns the figure around the point. Translation slides the figure to a different location. Now find the image that shows the reflection. Okay, so image A shows the translation. Image B shows the reflection. Reflect the shape across the diagonal line. Oh ho ho. So there is
What
one.
is this?
Okay, I'm telling you, there are three kind of reflection, not one kind of reflection. Okay, let me show you on the next page. Good one that we got to know earlier.
Yeah.
See how many kinds of mirror are there. So this is horizontal, this is river, vertical. Okay.
Yeah.
But there is one more beta. The other one is, you can say it is diagonal. So if you draw the diagonal part, this part
Oh.
will form here. Okay, so what I am doing is I am mirroring this line. This, I am taking the mirror image of this line. Okay, on the left side of it. Sorry. So I have to make the mirror of this line on the top of it, and okay, it is mirroring only with the x-axis. Okay, fine. Okay, let me explain it to you again. Now see this. If I want to, suppose this shape is not there, if I want to mirror this line across this, how I will do? So this is gone 2 steps, so I will take 2 more steps like this. Alright? This line has got 2 steps here. To make this mirror image with the diagonal, I will go like this. If you put the mirror like this, the image will form like this. Are you getting it?
Yeah. Yeah.
Okay. Now see this line, this red line, dotted line I am showing you. This dotted line goes up to 3 units above. So we will take 3 units to the right. Okay. And then we will join. We will go 3 units towards the right like this. And then we will join this point. And then we will get this as the result, this line.
Okay.
Are you getting it? So if you draw it diagonally, if you draw the diagonal image reflection, so that means let me show you that how diagonal works. So suppose you have a y-axis, you have an x-axis. So if I ask you what is the mirror image of this 3, 4, so there are 3 kind of mirror images. One mirror image is you take x-axis as a mirror, so you will get 3, -4, one of the image reflection, right? The other reflection will be with respect to the y-axis, and it will be -3, 4. Are you getting it? Then the third kind of the reflection will be towards this line, which is known as y is equal to x. This is origin. So if I keep this as a mirror, so this point which is towards this axis, it will come down to -3, -4. So the kind of reflection that was shown in the previous question is diagonal reflection. Diagonal reflection.
Makes sense.
Makes sense?
Yeah.
So I want you to do, please try out rest of the sheets by yourself.
Yes, sir.
Okay, and if any of the days you are having holiday, you can just let me know in the morning if you want to have a session in the morning. I am free after 11 a.m. So 11 a.m. to 1 p.m. I can take any time class. In the evening also I can take the class from 8 to 9 on any of the days.
Yes, sir.
Okay. Suppose you want on Monday or Tuesday or Wednesday, you can just let me know, because there is test going on. Next week I won't be available on Saturday probably, or Sunday, because I am going for some Ganga Snan. Okay, in Kumbh Mela I am going, and then from there I will be busy.
Oh, that's nice.
Yes. So if you are having any doubt on any topic, you can just let me know, sir, where I can find these topics in IXL. If you have any doubt to see those topics in IXL, I can just give you the reference. You can watch the video by yourself. You can do the questions by yourself. Right? Chalo.
Yes, sir.
Bye. Please do these sheets. Please do these sheets.
Yes, sir.
Okay. This is in geometry H1.
Geometry X1 and then pre-calculus A. Okay.
Yes. Chalo. Bye.
Bye, sir. Thank you, sir.
Okay, beta.
Thank you.